The mysteries of the universe are as vast and endless as the expanse of space itself. Among the most intriguing and enigmatic of these enigmas are black holes, which are regions of space where the intensity of gravity is so profound that even light is unable to evade its grasp. They function as cosmic vacuum cleaners, absorbing all matter that comes within their vicinity. However, despite the awe-inspiring nature of these phenomena, the question of how black holes formed, particularly in the early universe, has remained a topic of great interest to astronomers for decades. New findings using NASA's Hubble Space Telescope have enabled scientists to uncover a greater number of black holes in the early universe than ever before. This has opened a window into the origins of these massive cosmic entities. Consider the following scenario. The universe was less than 1 billion years old and still in its infancy. The formation of galaxies and the emergence of stars were still in progress, while black holes, some of which were as massive as billions of suns, had already come into existence. This naturally gives rise to the question of how this could be possible. The formation of supermassive black holes in the immediate aftermath of the Big Bang represents a significant challenge to current theoretical models. These are the kinds of questions that have long puzzled the scientific community. It is evident that supermassive black holes, which are situated at the core of galaxies, constitute a pivotal element in the evolution of galaxies. It has been observed that every major galaxy, including our own Milky Way, has a supermassive black hole at its core. However, the precise relationship between these black holes and the galaxies that surround them remains unclear. Did black holes form first, drawing matter in to create galaxies? Or did galaxies form first, with black holes developing in their centers later? Furthermore, how did these black holes become so large so rapidly? These are some of the most fundamental questions regarding the evolution of the universe over billions of years. A team of researchers from a number of countries, led by scientists at Stockholm University, has recently embarked on an investigation to address this enigma. Utilizing the capabilities of the Hubble telescope, the research team conducted a comprehensive survey of a population of faint, distant galaxies that existed at a point in time when the universe was just a few percent of its current age. The findings were unexpected, with a significantly higher number of black holes observed in these galaxies than previously anticipated. This discovery calls for a re-evaluation of the current understanding of the formation and growth of black holes. The team did not merely happen upon this outcome. Rather, they employed a sophisticated methodology to detect these black holes. The initial observations of these ancient galaxies were conducted several years ago, and Hubble subsequently re-photographed the same region at a later date. By comparing the old and new images, the team was able to measure minute variations in the brightness of some of the galaxies, which are indicative of black holes feeding on surrounding matter. The active feeding of black holes on surrounding matter results in the heating of the black hole and the subsequent emission of intense light, which causes the observed flickering or brightening as detected by Hubble. The groundbreaking nature of these findings lies in the sheer number of black holes that have been discovered. Previous methods of detecting black holes in the early universe had only identified a few, but this new survey suggests that they are far more common than was previously thought. This indicates that black holes may have formed much earlier and much faster than was previously assumed. However, the question remains as to how this could have occurred. One hypothesis posits that these primordial black holes were formed through the collapse of massive stars. In the early universe, the characteristics of stars differed from those observed in the present day. These were designated population 3 stars, characterized by a pristine composition comprising solely hydrogen and helium, the simplest and most abundant elements in the universe at that time. These stars were considerably more massive than those observed in the present day, frequently hundreds of times the size of the Sun. Upon reaching the end of its life cycle, a star of this kind would undergo a collapse under the influence of its own gravity, resulting in the formation of a black hole through an explosive event known as a supernova. However, there is an additional factor to consider. These colossal stars could only have existed in the early universe. As time progressed, the universe became increasingly enriched with heavier elements, which astronomers refer to as metals, produced by successive generations of stars. The presence of these metals inhibits the formation of stars with a mass comparable to that of the early giants. Therefore, the black holes that resulted from these massive stars could only have been formed at the earliest stages of the universe's existence, within the first billion years. It should be noted, however, that this is merely one theory. An alternative hypothesis is that some black holes may have been formed by the direct collapse of massive gas clouds. In the disordered environment of the early universe, dense clouds of gas could collapse directly into black holes without the formation of stars. Such entities would have constituted the seeds of the supermassive black holes that are observed today. An additional hypothesis is that of primordial black holes, which is arguably the most speculative and exotic explanation. These would have formed in the initial moments following the Big Bang, through processes that remain incompletely understood. According to some theories, fluctuations in the density of matter during the universe's rapid inflation could have resulted in the formation of pockets of extremely dense material, which would have collapsed into black holes almost immediately. These primordial black holes would have been relatively small in size, but as the universe evolved, some could have grown into the supermassive black holes that are observed at the centers of galaxies today. While this theory remains highly speculative, it is one of the many possibilities that are being explored as astronomers work to piece together the puzzle of black hole formation. As our knowledge of black holes continues to expand, it becomes increasingly evident that they play a pivotal role in comprehending the evolution of galaxies, and by extension, the universe as a whole. Black holes do not merely occupy a passive position at the centers of galaxies. Rather, they exert a dynamic influence on their formation. As black holes draw in matter, they emit energy in the form of radiation and powerful jets of particles, which can influence the formation of stars and even regulate the growth of galaxies. In a sense, black holes can be considered cosmic architects, influencing the formation of the universe around them in ways that are only beginning to be understood. The discovery of a considerable number of black holes in the early universe represents a significant advancement in our ability to comprehend the evolution of galaxies and black holes. However, this also gives rise to new questions. If black holes were more prevalent and more massive in the early universe than previously assumed, what implications might this have for our models of galaxy formation? This discovery raises the question of whether our current models of galaxy formation and evolution require rethinking. It is therefore pertinent to inquire as to the role that black holes play in this process. With the ongoing observations from the James Webb Space Telescope, which is designed to see even further back in time than Hubble, astronomers are optimistic that they will be able to detect even more of these early black holes. The Webb telescope's advanced instruments will enable the study of the light from the earliest stars and galaxies, offering an unparalleled insight into the universe's infancy. By investigating the universe's distant past, we can hope to ascertain the true origins of black holes and, by extension, gain a deeper comprehension of the universe itself. In conclusion, these findings represent a component of a comprehensive, continuous endeavor to chart the history of the cosmos. Black holes represent a significant, though not the sole, component of the larger puzzle. As our understanding of the universe continues to evolve, it becomes increasingly evident that there is still much to be discovered. However, with each new discovery and addition to our knowledge, we gain greater insight into some of humanity's most profound questions, including the origin of the universe. How did it evolve into the cosmic system that we observe today? Furthermore, it is pertinent to inquire as to the role that humans play in the vast cosmic narrative. The journey is as thrilling as it is humbling. The advent of telescopes such as Hubble and Webb has ushered in a golden age of discovery, with the secrets of the universe being gradually revealed. It is not possible to predict what will be discovered next, but it seems reasonable to suppose that the universe still holds many more surprises in store.